Good afternoon and happy Wednesday. My name is John Kowalski. I'm with the marketing team here at Pitt Gardner, and welcome to our office hours. If you're not familiar with our office hours format, we have our senior application specialist, Corey Cohen, going to give a brief presentation, maybe 20, 25 minutes long, and then after that we will open it up to for discussion, to answer any questions or challenges you may be having at your own facilities. So please enter any questions or comments you have or discussion points in the Q&A box located in the bottom right-hand corner of your screen, and we'll get to them in order following the presentation. Also, if you have some issues with the audio, in the chat box, I put in the call-in number and the meeting ID. You can log in via your phone. With that, let me turn things over to Corey. There you are, Corey.
Thank you, John, and welcome everybody. Today's topic is gloss theory and applications. So I'm going to start off just giving a little bit of the science behind gloss and gloss measurement, and then we'll talk about a few specific circumstances you might come across when it comes to gloss measurement. So here we go. Okay, so here we have a surface and a light source. And so when light hits that surface, a few things are going to happen. One is that you're going to get a specular reflection. You're going to get a reflection at the opposite angle to the light source, and that's what we refer to as the specular reflection or the gloss reflection. You're also going to get some of that light penetrating the surface, and it's going to interact with the pigments in that surface, which is what gives the surface its color. And then the light that comes off of the inside of that surface after bouncing around and interacting with those pigments is going to provide a diffuse reflection. So that diffuse reflection, again, there's been pigment interaction, so that light has now been colored by the pigments in the surface, so that's where we would measure color. That specular reflection is where we view or where we measure gloss. And that specularly reflected light is going to bounce right off the surface. There's no pigment interaction there, and so that reflection that you see at the specular angle is going to be the same color as the light source. So that's why you see when you're looking at a shiny surface and you're looking at the specular reflection of a light source, you see white, and that's what we call glare. So that's when you're actually seeing a surface at the specular angle. So here, again, we have a surface with a light source and an observer positioned at the specular angle. And so when it's a nice, smooth, glossy surface, a highly polished surface, when that light bounces off and goes into the observer eye, the observer is going to see a nice, clear, reflected image of that light source with good DOI, good distinctness of image. But now when we're talking about a matte surface, M-A-T-T-E, matte, meaning low gloss. So this is a rough surface, and that surface, because of its roughness, it's going to cause a higher diffused reflection where that light is going to bounce around and reflect off at all different angles. So you're getting more diffuse reflection, less specular reflection, and so the reflected image of that light source is going to be fuzzier and less distinct. And that's the basic difference between a low gloss and a high gloss surface. A high gloss surface has high specular reflection and lower diffuse reflection. A matte or low gloss surface has higher diffuse reflection and lower specular reflection. So knowing that, we can take that principle and use it to build a gloss meter. So a gloss meter, it's a pretty simple measurement principle. All it is a light source at a specified angle off the normal, and then a detector positioned at the opposite angle. And there's a lens both at the light source and the detector to collimate that light or make it so the light is traveling parallel, so it's all going the same direction. So this light beam has a certain width, and all of it is going in the same direction. It's not going to spread out like with a typical lamp. So that's the purpose of the lens, is to make a parallel light beam that's all going the same direction. And so the more light that's picked up by that detector at that specular angle, the higher the gloss measurement. So we typically deal with three standard gloss geometries, 20, 60, and 85, and these are specified in international standards. These are standardized angles that are used, in industries worldwide. And so you can see that each of these light sources at the specified angle off the normal. So we have the 20-degree geometry is 20 degrees off the normal, 60 degrees is 6 degrees off the normal, same with 85, and each of those light sources, of course, has its own detector positioned at the specular angle for that particular light source. So why do we need three different gloss angles? The purpose is to be able to measure the full range of gloss from very low gloss to very high gloss. And the reason we need three different angles for that is shown here in this graph. So here we have on the horizontal axis, these are 13 different gloss panels increasing in gloss from 1 to 13, 13 being the highest gloss, 1 being the lowest. And the steps between these panels are visually equal steps, meaning the visual difference in gloss between the 1 and the 2 panel is about the same as the visual difference in gloss between 2 and 3 and between 3 and 4 and so on. So equal steps in visual gloss from 1 to 13 on the horizontal axis, and then on the vertical axis, we have measured gloss in gloss units. Gloss units is the common scale used for measuring and giving gloss numbers. So we can see here the 60-degree measurements of each of these 13 gloss panels and how the when you put them all together in this graph, sort of the shape that this curve gives us, you can see that in the low gloss range, that curve is very sort of flat and not changing very much. It's not really until it gets to the semi-gloss range that it's getting nice and steep. It has a nice steep slope to it. It's fairly linear in that range. And then once we get into the high gloss range, it flattens out again. And so this is showing us that the 60-degree geometry is really ideal for the semi-gloss range and not so much the low gloss and the high gloss range. I'll give you an example to show you why that is. So suppose we want to measure the difference between the 7 and the 8 gloss panel. So we measured the 7 with our 60-degree geometry meter. We measure the 8 panel with that same meter, and we get a gloss difference of something like 16 or 17 gloss units. So we're seeing a clear visual difference between the 7 and the 8 panel, and our 60-degree gloss meter is measuring a nice, clear, distinct difference between those two panels. But now I want to measure the difference between the 11 and the 12 panel. And now, even though the visual difference between the 11 and the 12 is the same as that between the 7 and the 8, now I'm only measuring a difference of maybe 3 or 4 gloss units. So even though visually it's the same difference, my 60-degree meter is going to measure it as being a much smaller difference. So the high gloss range is not optimal for the 60-degree meter. So that's when we might switch to the 20-degree geometry. So you can see at lower gloss levels, that curve is fairly flat. It's not measuring very large gloss differences between those lower gloss panels. But as we get into the higher gloss range, we get a nice steep, even slope. And so our measured gloss differences are much wider, and it's matching better with what we see visually. And similarly with the 85-degree geometry, we have a nice steep slope in the low gloss range, and it doesn't work so well in the higher gloss range. So this is the reasoning behind having 3 different gloss geometries. And so this is the general recommendation that we make for when to use the different geometries. If you take a measurement of your surface with a 60-degree geometry gloss meter and you get a value between 10 and 70 gloss units, we would say that's the semi-gloss range, and it's best to use a 6-degree geometry meter for materials in that range. If you measure a material and get a value of greater than 70 gloss units with your 60-degree meter, we would say that's the high gloss range, switch to a 20-degree geometry. And if you take a reading of your material and get less than 10 gloss units, again with your 60-degree geometry, we'd say this is the low gloss range. and you should switch to an 85-degree geometry. So these are just kind of rough conventions. It's not set in stone. You don't have to use the specified geometry in those gloss ranges. It's just what's recommended. So you might be asking, what is a gloss unit? And that's a fair question. So the gloss unit scale was based on this particular black glass. Back when gloss meters were first invented, they took a black glass, a very smooth, polished black glass, very high gloss surface, and it had a refractive index of 1.567. And they said this very polished, highly smooth, highly glossy black glass has a gloss value of 100 gloss units. So that's sort of the origin of the gloss unit scale, and all measurements since then have just sort of been based on that original black glass with, materials that are lower gloss measuring at lower than 100 gloss units, materials at higher gloss measuring at higher than 100 gloss units. But we can see from this chart here that it's not true for every material, every refractive index. The measured gloss you get is actually dependent on the refractive index of the material. So these are all different black glasses. They're all very highly polished. They all look very similar. They look like they're at the same gloss level, but because of that difference in the index of refraction, we're getting different measured gloss values depending on that number. And so what this tells us is that gloss measurements are actually dependent on the material. They're dependent on the refractive index of the material. And so you could actually get, even though two materials may look to have the same gloss, if they are different materials with different refractive indices, you can actually get different measured values. So this leads us to the recommendation that you should really only compare gloss measurements of materials with the same refractive index. And so it can be very tough trying to compare different paint systems that might have different refractive indices. You really only want to compare gloss with the same type of material. So our gloss meters, you can purchase them with an individual geometry. You can purchase a 20-degree meter, a 60-degree meter, or an 85-degree meter. And they also come in the micro tri-gloss meter, which has all three angles in one. And one other thing to note is that it has what we call an expanded measurement range. You can measure the full range of gloss up to 2,000 gloss units. And I'll get to why that is a little bit later. First, I want to show you this example of a weathering test. So here we have two different coil coating systems represented by panel A and panel B, and these panels are undergoing a weathering test. So the gloss of these panels is measured by a 20-degree geometry meter and by a 6-degree geometry meter at the start, and they're weathered for a certain number of hours, and a gloss is measured after 100 hours of weathering, after 200 hours of weathering, and after 250 hours of weathering to see how well the gloss will hold up and how quickly that gloss is going to change over time, which is a pretty common type of weathering test to see how well a material will hold up to time in the elements and see how much the gloss is going to change over time. But we can see these four curves here. We have that purple and green curve at the top representing the measurements of panel A and B by the 60-degree geometry. And you can see that they don't really change very much. After 200 hours, we're not seeing a whole lot of change in the gloss level with the 6-degree measurements. After 250, we do see a bit of a drop in panel B. Pretty significant, not huge, but we are seeing some significant differences. But when we switch to the 20-degree geometry, and we can see when we're starting off, the 60-degree measurement of these two panels is at around 90 gloss units. So if you remember back to our recommendations of when to use which gloss geometry, we would say this is the range where you really should be using the 20-degree geometry. And so if we look at those 20-degree curves, the blue and the pink curve, we can see that the gloss is actually changing a lot more drastically than we might have thought just based on the 60-degree readings. So this is why we recommend using a 20-degree geometry at high gloss. It's just sort of a real-life example of that. But also why we generally recommend getting the tri-gloss meter that has multiple gloss geometries, because when doing a test like this, you might start off at the high gloss range, but you can see after a certain amount of weathering, these panels are dipping down into the semi-gloss range. So it can sometimes be good to have data from multiple geometries, not just one. And I do want to mention at this point, if I haven't made it clear, different gloss measurements taken with different geometries are not comparable to each other. You can only compare 20-degree measurements with 20-degree measurements, 60 with 60, and 85 to 85. It's a common question I get asked all the time, but there is no conversion from one gloss geometry to another. Okay, so going back to that gloss unit scale, this scale based on this polished black glass, which measures at 100 gloss units. In most materials that we deal with, paints and plastics that are going to measure at 100 gloss units or less, they're going to max out at about 100 gloss units, maybe a few gloss units higher, but it's really not going to get much higher than that for paints and plastics. Now metals, the reason for that is because paint and plastics, they absorb a certain amount of the light, whereas metals like aluminum are going to have near total reflection of all the light hitting the surface. And so there's very little absorption, little to no absorption with metals. And so the possibility exists to get much, much higher gloss values with metals than with things like paints and plastics. And so that's why our meters have this expanded measurement range where at 20 degrees you can go up to 2,000 gloss units, 60 degree goes up to 1,000, and you wouldn't really ever want to use an 85-degree meter with a polished metal, but they can go up to 160 gloss units. I also want to go back and mention that in addition to the gloss unit scale, you can measure in percent reflectance. And that percent is just the percentage of gloss units out of the full scale for whichever geometry you're using. So for example, here at 20 degrees, the maximum number of gloss units, the max scale is 2,000 gloss units. So you would just take the reading in gloss units and divide that by 2,000 and then multiply by 100 to get your percent reflectance. So generally, paints and plastics are going to be measured in gloss units because it has sort of better resolution. But when you get up into the hundreds of gloss units range, when you're measuring metals like aluminum, that's when you might want to switch to percent reflectance. So gloss on curved surfaces can be difficult, and you can see why from these graphics here. So ideally, gloss is always measured on a completely flat surface, because that makes the geometry of the measurement very easy. Gloss can be measured on a curved surface, but the difficulty with that is that the light beam from the light source in this gloss meter, it's not an infinitely thin beam. It does have a thickness to it, and that means when you're dealing with a curved surface, different parts of that beam are going to hit different parts of that surface, and just due to the curvature of the surface, not necessarily due to the gloss or lack thereof, but just due to the curvature, different parts of that beam might bounce off at different angles and miss the detector. So in general, for the same visual gloss, you're typically going to get a lower measured gloss value on curved surfaces than you would on flat surfaces. So again, it is recommended to always compare curved surfaces to curved surfaces and flat surfaces to flat surfaces, because you always want to be comparing apples to apples, and you don't want to get a comparison that isn't exactly accurate. So another application of a gloss meter might be measuring the gloss on a transparent material, some kind of transparent film or glass or clear plastic. And one of the implications of that is that clear materials, no matter how thin it is, you're always going to get a dual reflection of that light beam off of that material. You're going to get some light reflected off of the top surface, some light reflected off of the bottom surface, and then some of that light that's reflected within the material is going to bounce around, and of course that's going to miss the detector. So you're always going to get different gloss values on transparent materials than you would on solid colored materials. And this is also why we recommend, again, measuring or comparing values taken only on samples with similar thicknesses. If you compare measured gloss values on samples with different thicknesses, you might get different measured values even if the apparent gloss, the visual gloss, is the same. And for measuring transparent samples, we always recommend measuring that over a matte black background. So maybe a piece of black felt, or perhaps a low gloss, if you can find like a dark colored tile, that's the best backing to use for transparent materials. So that's all for my brief presentation, and now I'll give it back to John for our Q&A.
Thank you, Corey. Great information. And for everyone attending, we are recording this, and we will send that link along with the presentation materials with our follow-ups in the next day or so. So look for that. One question in here, are there other gloss geometries other than what you—
There are, yes. Yeah, aside from the 2016-85, we do have 45 degrees and 75 degrees. Those are sort of our specialized gloss geometries. 45 degrees, hopefully I'm not mixing this up, I believe 45 is typically recommended for things like paper or paperboard. And then the 75 degree is the specialized gloss meter for plastics.
Okay.
Plastics don't.
Great, thank you.
That.
All right. I have another question here from Christopher. Since the diffuse reflection will be part of the light measured at the gloss angle, doesn't color affect the gloss measurement?
That is an excellent question. It can, certainly, yes. Some of that diffused reflection is going to reflect off at the specular angle, it can. Now, typically for high gloss surfaces, the color, the specular reflection is going to so overwhelm any diffuse reflection that you get at that angle that the color really isn't going to make a difference. It's really for matte surfaces, lower gloss surfaces, that yes, you might see some slight differences in gloss measurement between measuring a white versus a black.
Okay, Christopher, I'm going to unmute you. Did that answer your question, sir?
Yes.
Yes, okay.
Thank you.
Great, thank you. You bet. And we have another question from Teresa. Can gloss unit value change color rendering? For example, a frozen clear coat over a blue base coat compared to the same blue base coat under a high gloss clear coat. Want me to read it again?
No, yeah, I understood the question, and the answer is yes. Gloss definitely can affect how we perceive color. Typically, glossier surfaces appear darker to us and maybe slightly more chromatic, even when the pigmentation is exactly the same. And this is actually the primary difference between sphere and 45-0 measurement geometries for color measurement. 45-0 instruments measure color as we see it, meaning for 45-0 instruments, gloss is going to affect the color values you get. And glossier surfaces will be measured as darker with that instrument, just like how our eye sees it. Sphere instruments are going to ignore that effect and only measure the pigmentation.
Teresa, I'm going to unmute you. Did that help clarify? Teresa, are you there? You are unmuted. Just want to make sure that your question was answered. Okay. Not sure where Teresa is. Next question here from AJ. Have you guys ever experienced different measurement values based on the contact pressure used to measure a specimen? For example, using more or less pressure to affect the measurement. Is there a best practice to recommend?
Yeah, so when you're talking about non-rigid materials, that can definitely affect the alignment of the material under the aperture, and yes, it can affect the gloss measurement. Obviously, that's not a problem for rigid materials like glass or a fully cured paint. Usually isn't going to be affected by that, but if you're going to be measuring like a film, a plastic film, yeah, it can, and that's so. That's why, so like when I recommended using either a black felt or a black tile as the backing for a transparent material, black felt is not going to be so good for non-rigid materials because you are going to have to press that gloss meter into it a bit, and that will throw off the alignment. So if you're dealing with something that's very flexible, you want to use a very hard backing that's not going to cause that flexing under the aperture.
Okay, great. Thank you, Corey. AJ, did that answer your question? I'll unmute you here.
Can you guys hear me?
Yeah, we can. Yeah, there you are.
Yeah, so I was just wondering, we have an application that requires us to measure gloss of just different plastic parts that we're using. And my quality team and I were chugging through some measurements, and I noticed that the harder that I push on the measurement device itself, the lower the gloss value actually became. So I didn't know if you guys could recommend, say, is it proper practice just to use the device's weight and then just try to take the measurement with minimal contact pressure from your hand? Or, if I'm supposed to put, let's say a medium pressure on the device just to make sure that contact is being fully made?
I'd say the first thing you said would be best. Yeah, just let the weight of the gloss meter be the only pressure on it, and try the button for our gloss meters is on the side. So try to only press it from the side and not apply any downward pressure, and you'll probably get the most consistent measurements that way.
Awesome. Thank you, guys. That answers it.
You bet. Thank you. Good deal. Okay, next question here from Janelle. Can you explain again the method on how to decide which angle needs to be used for your measurements?
Yes, let me go back to that slide. So this is the convention, and we can send this presentation to you so you have this. And so when making that determination, you do want to measure with a 60-degree geometry just for the purposes of figuring out which geometry to use. Because again, you are going to get different measurements, different numbers, depending on which gloss geometry you use. So this convention here is based on the 60-degree measurements. So if you measure your surface with a 60-degree geometry and you get between 10 and 70 gloss units, we would say keep using the 60. If you get greater than 70 gloss units, again with your 60-degree meter, switch to the 20. And if you get less than 10 gloss units, go to the 85.
Janelle, did that answer your question? I'll unmute you here.
Yes, it did. And I assume that this is the principle then that was applied when you showed the example of the UVB testing explanation. So you did a baseline at that 60-degree geometry to see where you lied, and then changed, obviously, the 70 we were above 70 units, and then the 20-degree new evaluations showed the bigger differential.
Right. Right. Exactly. Yes, it was in the according to this, into that high gloss range, and so we saw that was showing larger differences between the two panels. Again, I just want to reiterate that this is not set in stone. There are plenty of industries using the 60-degree geometry in both the high and the low gloss range, and they make it work. We actually do provide a high precision gloss meter. If you have a need to measure gloss, 60-degree gloss in the less than 10 gloss unit range, we provide a meter with better precision so that you get clearer differences, and the uncertainty in the instrument is going to count for less when measuring in that range. Because again, you do need to, if you want to compare values, everyone has to be using the same geometry. And so if someone that you need to compare values with, a customer or a supplier or a sister plant, is measuring in that glow gloss range with the 60-degree geometry, you can't just decide, oh, I'm going to use the 85, because then you won't be able to compare measurements.
Right. Yes. Yeah.
Okay. Great. Thank you. You're good, Janelle?
Yeah, I'll type in another question though, so it's not exactly follow-up, but
Here we are.
what would you consider permissible variation, like between, say you and your sister company are measuring the same sample using the same geometry for for the gloss meter itself, but you and your sister company have different pieces of equipment. What would you consider permissible variation between two different pieces of equipment, and that you're seeing the same or relatively the same gloss value?
So we always say, measurement uncertainty, that's just a part of life. Every instrument, no matter how well built, is going to have some uncertainty in the measurement. And we like to say that your uncertainty should account for 1/3 or less of your tolerance. So if your tolerance is plus or minus 2 gloss units, your uncertainty in the measurement should be less than 1 1/3. Does that make sense?
I think so. Yeah. Probably we need to set our own tolerance first, and then it would make more application or more sense for our group. But yes, I think so. You said 1 1/3 or just 1/3?
If we're talking plus or minus 2 gloss units, that would be an overall tolerance of 4 gloss units, and so we'd say the uncertainty should be, well, plus or minus, in that case, 2/3 of a gloss unit is what I should say.
Okay, narrow your tolerance down. Okay, by 1/3.
So can I add to that? This is Geraldine Camp.
Yes.
I've had this question before. What is a good tolerance? Generally speaking, whatever the target is, the gloss range is, or say your target is 80. Generally speaking, it plus or minus 10% is a good range to start with. So you at least know, higher gloss ranges you need a wider tolerance. The lower your gloss range goes, you need to tighten up your tolerance, because gloss starts to become very, very apparent when you have a difference of something at 2 and a difference of something at 4. They don't look the same, and so those 2 gloss units at very low gloss are more obviously different. And then if you're 80 gloss, you can have a tolerance of plus or minus 8, so 72 to 88. So you can do that, because it's very difficult for humans to identify the difference in gloss the higher the gloss goes. And depending on the application and how sensitive the gloss needs to be, you can tighten it up if you need to, or open it up if you need to.
Okay, that makes sense based off of that initial graph as well, where he showed the measure values versus the visual values. Yeah. Okay.
Well, hopefully that'll help you start setting your tolerances.
Thank you. Appreciate it.
You bet. And thanks, Geraldine, for jumping in, and Corey for your excellent answer. Next question here from Mike. Can gloss be measured with a SpectroGuide sphere gloss S on a textured surface?
Yes. Textured surfaces are always going to be a bit tricky for gloss because you could have, that light beam is going to bounce off in different ways just due to the physical shape of the surface, the texture in the surface, and not necessarily due to differences in gloss. So gloss can tell you, certain things about textured surfaces to an extent. We do have a new instrument out. It's called the Spectra 2 Profiler that is designed specifically for measuring textured surfaces. And it actually uses a type of measurement called 2D reflectivity, which sort of overcomes the difficulties that a gloss meter has in measuring textured surfaces. And it also measures the topography of the surface in order to help you make sure that the texture is consistent from batch to batch. So if you do have difficulty measuring textured surfaces with a gloss meter, you might look into our new profiler instrument.
Okay. Mike, did that answer your question, sir? You're unmuted. You there, Mike? He might be having some audio issues. I did get a message too from Teresa. Yes, microphone is not working, but that did answer her question. And a follow-up to that. Are there any known instruments to measure color for low gloss clear coats? In parentheses, 15-35GU.
Oops. Didn't mean to switch slides. That has nothing to do with this question. I mean, yeah, any color instrument, whether it's 45-0 or sphere, will be able to measure color on any range of gloss surfaces. It's just a matter of how you want those color values to reflect how the gloss is affecting the surface. So just to reiterate, 45-0 glossier surfaces will be measured as being darker and slightly more chromatic. Sphere instruments are going to ignore the gloss and only measure the pigmentation. So the gloss will have no effect or very, very little effect on the color measurements you get with a sphere instrument. So you just have to decide, what's important to you and what you want to see in your color numbers.
Okay, great, thank you. Teresa, if you need any clarification, just type it in and I'll read it for you. Another question from Mike here. How accurate is reading gloss using the same meter if the surface is not flat, say convex?
It's tricky, and it really has to do with positioning. So there are two ways you can go about this. One is you can create kind of a jig that you can set your sample, assuming that your samples are all, excuse me, all going to be the same shape. If you can set your sample in a jig with the meter positioned exactly the same way on it each time, you should get very, very good repeatability from measurement to measurement. The other way that you can do it, what I sometimes like to do when I'm taking gloss measurements of curved surfaces, is our gloss meters have what we call continuous mode, where it takes a gloss measurement every second or whatever interval you set it to. And then at the end, it will give you statistics on those measurements. It'll show you the maximum value, the minimum value, the range. And so what I like to do is put it in continuous mode and sort of just slowly roll the meter across that curved surface, just very, very slowly, give it enough time so it can really hit that sweet spot where it's perfectly tangential to the surface. And then when I stop the measurement, it's going to give me the maximum value that it measured, and I can take that maximum value as the gloss measurement when it was in that perfect position.
Okay, great. Thank you, Corey. Another question here. What does sheen mean versus gloss? Also, what was the, yeah, go ahead. I'll let you do that one first.
Sheen is just another term for gloss. They mean the same thing.
Okay. Also, what was the result of measuring gloss on a transparent surface?
The result, can you clarify that question?
He doesn't have a microphone. He did put in there. So if you wanted the person that asked the question, he or she wrote in they don't have a microphone. So if you could go ahead and clarify a little bit in the chat, we can get right back to that. Oh, he's just wrote, does the gloss tend to be higher or lower?
I'd say for the same visual gloss between a solid colored surface and a transparent surface, the transparent one would have a lower measured gloss just due to how some of that light is going to be lost by bouncing around the inside of that material.
Okay, thank you. Another question here from Diana. Does it mean there's no way to get a high value at low, or sorry, let me start again. Does this mean, oh, I need to scroll up now. Where are we going? Does this mean there's no way to get a high value at high angle and a low gloss value at a low angle?
A high value at a high angle.
Yeah. Diana, let me unmute you here. Would you mind clarifying a little bit?
Yeah, so looking at the graph, it looks like you can only have 85-degree gloss if your 20-degree gloss is like low. So is there no way that you end up with high gloss values at the 20-degree and low gloss values at the 85? I was thinking like maybe there was something about how the surface was featured that you could maybe get it to do that, but I don't know.
I wouldn't take this graphic as gospel for the exact relation between 20 and 60 and 85. It's just meant to be sort of visual representation. But I mean, I think the thing to remember is that it's all relative. There are a lot of variables when it comes to measuring gloss, as we've seen in this presentation, things like curvature, things like refractive index, things like the transparency of your material. They're all going to have different effects on the overall gloss value that you get. So the important thing is really just to, again, a term we throw around a lot, apples to apples. You want to make sure that you're always measuring the same types of surfaces in order to get comparable measurements. And so, a reading of 80 gloss units on one material might be equivalent to a reading of 100 gloss units on a different material. You just really want to, it's a relative measurement. So just make sure that you're comparing it to the right things.
Okay, thank you.
All right, thank you. Another question here, what's the best way to clean a standard black panel?
We recommend actually using nothing more than just your breath to create a little bit of moisture and then wiping it with a lint-free cloth. That's really the best way to keep it clean. If it really is dirty, if maybe there's a fingerprint on it and some oils that you need to get off, you can clean with alcohol. But alcohol does sometimes leave behind a bit of a residue. So you might want to clean with alcohol and then again, just with a little bit of moisture. But we don't recommend anything harsher than alcohol. For example, acetone is going to eat away at that material and change the gloss value.
Okay, thank you. Question here from AJ. Is there a best practice variation limit for gloss measurements on the same part? Say you need to measure 4 areas on one part. What variation level would raise an alarm for your team? Greater than 1, greater than 2?
So it really has to do with what you see visually. All these measurements, all this stuff is really just meant to replicate what we see visually and to align the numbers with what we see visually. So, visually you can't tell the difference between, a 5 gloss unit spread, and that's what you can use as your tolerance. If you're seeing visual differences, at 2 gloss units, then you need to tighten up your tolerances to that level. And I think what Geraldine, the guidelines Geraldine gave are some good basic starting points to use, just 10% of your measured gloss value to start with, and then maybe take some measurements and compare the visual and see if that works for you.
AJ, on you again. Did that help?
Oh, for sure, guys. Yeah.
Questions?
Yeah.
Okay.
Thank you guys so much.
You bet. Excellent. Teresa here sent in another question. We spray vehicles in series in high gloss clear coat, and some also run as frozen low gloss variant. Can you accurately compare data from a Bic Mac eye for a glossy 80 GU plus blue panel and a low gloss 25 GU blue panel?
Yes, I'd say because the Bic Mac, the multi-angle color instrument, it has a directional light source, which makes the geometry similar to the 45-0, where it's going to measure color as you see it, and the gloss differences are going to have an effect on the color differences. So even if you're dealing with 2 surfaces with different gloss levels, as long as you align the color values at each angle, visually those 2 surfaces should look very similar to each other, up to a certain point. If there's too much gloss spread, no amount of messing with the color is going to make the 2 materials look the same. But yeah, you can, to a certain degree, mitigate gloss differences with color, with aligning the color to look the same.
Okay. Teresa, that answers your question. Thank you. You're welcome. You're welcome. If anyone else has any questions, please enter them in the Q&A box and we can get to them. We have a lot of experts in addition to Corey on the phone here, and would love to help you out in any way or help you address some of the challenges you're experiencing in your own facilities or labs. We will be sending this information out along with a recording of this. You should receive that in the next day or so to review, to pass around, share with your team if there's any other interest. And as always, too, don't hesitate to reach out to us, either your local regional sales manager, someone from inside sales. Corey has his email address right on the screen there. You can jot that down and email him any questions you may have as well. There doesn't seem to be any other questions here. We can hang around for a little bit more. Geraldine or any of the regional sales managers, are there typical questions that you guys get frequently out in the field?
Corey answered one that I often get. A lot of times people report gloss in percent, and then it actually is gloss units. Percent is percent reflectivity. So, the people think that, if gloss goes from 0 to 100 and I have an 80, that's 80%, and it's not accurate. It's 80 gloss units. It's probably one of the most common I get. And then, questionable 60-degree results at less than 10. I try to warn them that the standard gloss meter is probably eating up maybe at least 50% of the tolerance for the instrument itself. So, to keep those tolerances tighter, most gloss meters can't really effectively work for you at low gloss. That's using the 60 degree. So 85 is best to add to your data collection, or to get, like Corey mentioned, the high precision 60-degree gloss meter. That's the most common questions I get.
Thank you. And that seems to be all of them. Nothing else from our attendees. So with that, I think we'll wrap up. Thank you again for your time, and hopefully this gave you some value and some good information to bring back to your teams. If at all, reach out to us if we can help in any way, and look for additional webinar invites. Thank you very much, and have a great rest of your day.
Thanks, everyone.